This integral is not really easy because you have absolute value of sine x. Absolute value, sine x is oscillating function from a positive to negative. So if you integrate from 0 to infinity, that would be, so many subintervals, right? From 0 to this one, sine is positive, right? Then next interval from 0 to pi, from 0 to pi is positive. From pi to 2 pi, sine is negative. Sine will be negative, right? So negative. And then from pi 2 pi to 3 pi, then sine is positive. And then from 3 pi to 4 pi, sine is negative again. And so on. It's alternating the sign for each interval of a pi. So it becomes a series of integrals. Now, there might be a way to find, but it's very complicated. Let me try use some nice trick. Okay, I let x equal to t minus pi. Therefore, t is equal to x plus pi, isn't it? Then integral 0, when x is 0, t is pi. When x is infinity, is infinity. And e to the pi minus t, isn't it? That's x. Now, sine t minus x, sine t minus pi is equal to negative sine t, right? Because absolute value is the same. Therefore, it is sine t and the dt. Because sine t, negative, positive, there's no difference. Absolute value sine t is always positive. So no matter sine t is negative or positive. So that would change the integral into e to the pi multiplied from from pi to infinity, e to the t and x is just dummy variable. Let me write x. Negative x, absolute value, sine t, and dt. See? It's a very, very nice way to change the integral. Now then this one is equal to e to the pi. This integral, compared to the given integral, you're missing one section, right? In other words, this one is this one minus one section. So this one is from 0 to infinity, e to negative x, absolute value sine x, dx. Take away one interval, which is from 0 to pi, e to the negative x, absolute value sine x, dx. See, this minus this one is this. From 0 to infinity, minus from 0 to pi, remaining from pi to infinity. That is the story. See, the reason is that The reason doing this one is good because this is my original I, right? This is e to the pi equal to multiplied by this is I minus from 0 to pi e to the negative x. Now from 0 to pi, sine x is always positive. Therefore we can delete that absolute value sine. See, now everything can be done, right? This side is I, right? This is side I. I move this one over there, change this one to positive, so this will become I e to the pi minus 1 is equal to e to the pi integral from 0 to pi sine x dx. Yeah, this one times the move there, changing the sign. This one changes sign, become positive. Therefore, everything can be done. I believe that you have done this integral when you learn by parts. You must have done that kind of integral. So let me save time. Okay, I suppose you know how to do this one, right? By parts twice, and you get the result. That result is equal to half e to the negative pi plus 1. Okay, this is this integral. Okay, excuse me to skip this step. I suppose you know how to do this integral by parts. So therefore, my I is equal to this one, e to the minus 1 times half. This will be 1 plus e to the pi, right? Then we simplify this one is equal to half e to the pi minus 1 plus e to the pi. So that is the result of this looks very, very difficult integral. Okay, here we have a nice trick such that we change this integral to delete the absolute value sign, then everything is done nicely. Thank you.